So after like 5 years of checking, trying it at an independent telescope, you've satisfied yourself that, oh my goodness, yeah, we have this signal. So you published, and there was quite a lot of media attention at the time. What was the response from other scientists?
I think there was a mixture of like, wow, exciting, amazing, so glad you did this, tell us more. And a bit of a mix of like people like totally taken aback of like looking at the wrong planet for life. There's got to be something wrong with this work. So that was a bit of a difficult time of people who didn't know us going, nope, you've just done it wrong.
Yeah, I think some people were suggesting that you might have misidentified the phosphine for something else, or they didn't like the way the data had been processed. So it was a lot of trying to think of other possible explanations that didn't involve phosphine.
Exactly. So the following 5 years has been, more checking, more thinking of other ways of doing it. We're actually trying to simplify the data processing. We've managed to get more data now, particularly the James Clerk Maxwell Telescope have been really generous and given us something like 200 hours to try lots more things. And that enables us to look at other molecules at the same time. So one of the things I thought that'd be misidentified was maybe it was sulfur dioxide, which absorbs at a quite close but not identical wavelength. And so with simultaneous observations of both molecules, we were able to rule that out, and we can carry on doing that. And with the huge wealth of data, we can use techniques for cleaning up the data that are a little less like 140 spectrum one by one, and a little bit more like here's a systematic understanding of how the instrument works. I think the chances that we've got it completely wrong are now really, really small, because we've looked with about like 3 telescopes about 6 or 7 different times now, and it's never been like really definitely not there. So I think, my heart, that's pretty solid.
Do you think that there are certain sort of prejudices or biases that come into play when it comes to looking for life elsewhere? Because quite often we'll get these sort of tentative results of, oh, this could be something interesting, and then everyone piles on and goes, that should never have been published. And coming up with other possible explanations. It's quite a heightened debate, isn't it? Sort of something gets put out and then everyone kind of jumps on it.
Yeah, that does happen. And in a way, that's like the proper thing, that you should really look hard at the data. I think what's not nice and we weren't expecting is a pile on of like thinking or saying the people who did the work are either not competent or they like overstated their results on purpose to get attention. And things like the detection of methane on Mars, which isn't necessarily a biosignature. It could be like pockets of old volcanic gas, but it could be, some still extant microbes under the surface. I mean, to me, that's super exciting. And there are very different measurements if I do very different techniques. But if it comes to people like insulting instruments that other people have carefully built over many years, I think that's not a right thing to do. It's more about reconciling the data in like a polite way.
The response you got, I'm just wondering what toll did that take on the team? Have you ever regretted doing that because of the response that you got?
Personally, I have occasionally regretted it when I felt really under pressure and actually being called like a charlatan or an exhibitionist or something. And those were not my motivations. And we, like I say, we tried to do proper open science and release like products from the data that citizen scientists, people could use that didn't, you didn't have to come through us. You didn't need special training or skills. We wanted like anyone to be able to look at the spectra. So it felt like a bit of a slap in the face to go like, oh no, we're going to do something. Actually, we won't disclose necessarily what exactly we did. And then we're going to call you wrong. And that's what I think what science needs to do better. Like we would have loved if people had just phoned us up and went like, I think you must be wrong, but let's chat about it and let's use, my expertise to check with you and come to an agreement. That would be a nice scientific world to have.
Why do you think it gets so personal?
I think sometimes people take things by surprise. And I think as humans, we have a sort of natural inertia to go, if something sounds really crazy, then you're like naturally not going to believe it as a first step. But also there's other things like people maybe have been really focused on, like Mars is such an amazing place to go to look for signs of life, even if it died and it was in the past. That there's a bit of oh no, I don't want the attention to go somewhere else because maybe, my next billion-dollar mission might not go to the right planet. So there can be a bit of like, I think, feeling inside people. Like, it's odd how people only think they can work on one planet. I'm not sure why that's a rule. But perhaps like people are anxious that the money goes where they see it's best spent.
It does seem sometimes as well that it's quite all or nothing. Like there's almost like it's kind of seen as you shouldn't mention any possibility that something could be due to life until you've got cast iron proof. Like it's quite hard to have the conversation of, well, it might be this or it might not. So just to be able to sort of explore in an open-minded way what different explanations for a result might be.
Yeah, and I hope we tried to be really careful with that. I mean, when we revealed the phosphine result in 2020, we said, we're not saying this is life. We're just saying it's a molecule that can be produced by life. And you need to be careful that way, to not get too excited, I think.
It does seem that there's this kind of assumption that life is incredibly difficult and rare and likely only to be on Earth, and we're not going to sort of overturn that view unless we have incontrovertible proof. But presumably you could think of it the other way almost, that perhaps the most, we know there's life on Earth. That's the one sort of situation that we know for sure. So why not think that life could actually be really easy to form? Yeah,
I think the incontrovertible proof is going to be difficult, but finding lots and lots of signals it could say, like, we can't explain away all of them. So I remember when the first extrasolar planet around a star like the Sun was announced in 1995, because it was jiggling the star about. I do remember scientists then saying, like, this is just a bad orientation. It's not a planet jiggling the star about. It's another star. Don't think there are planets. And then, within a couple of years, there were so many planets. It was like, you can't make this, other explanation work for all of them. So, yeah, I'm hopeful that searches of exoplanets, maybe finding several molecules in each, all of which together make sense. Like if you looked at the Earth from another star system, you'd see, oxygen and ozone and methane and carbon dioxide and things you could put together as a picture of a living planet and say, well, that looks really different to a non-living planet. So I hope we'll be in a position to do that.